Hello everyone, welcome to the Solutions Basket. Today we are discussed the next questions in this video based on the engineering mechanics. In our last video we are discussed 6 questions based on engineering mechanics and the link of that video is in the description box. So the seventh question is a particle in equilibrium cannot have. We need to find in this question that a particle which is in equilibrium is not have. So what is the correct answer is a particle in equilibrium can have a linear motion with constant a linear motion with constant speed. This is correct correct option. Correct means this condition is satisfy the equilibrium condition of a particle, but we need to find the condition that is not satisfy the equilibrium condition for a particle. So second question is constant velocity. This one is also correct. Zero acceleration, this one is also correct, and zero velocity, this one is also correct. But a curvilinear motion with constant speed, this one is incorrect, but according to the question this one is the correct option. So let's move to the next question. If two of the three concurrent forces in equilibrium have equal magnitude P and angle alpha between them, the magnitude of the third force. So let's sorry yes. So this is our condition. A particle if two forces if two of three concurrent forces in equilibrium, these two forces is in equilibrium, this one is P and this one is also P, because they have equal magnitude and the angle between them is alpha and the resultant force equals to R. So we know the formula for the resultant equals to R is square equals to P square plus Q square plus 2PQ cos alpha. Square equals to, here in the question, P equals to Q, that is P. So P square plus P square plus 2P into P, and the alpha is same, alpha. R square equals to P square plus P square plus 2P square cos alpha. 2P square plus 2P square cos alpha. 2P square is common in these two terms, so 2P square is common, and 1 plus cos alpha. This is our answer, but in the options there are some more specific answer. So we need to further solve this term. So when we solve this, we find the answer is that 4p square cos square alpha by 2, and here is r square. So the value of r is equals to 2p cos alpha by 2. Here we applied the formula of cos 2 alpha equals to 2 cos square alpha minus 1. Here is only here is not the 2 alpha in the question, so cos alpha equals to 2 cos square alpha by 2 minus 1. Hope you understand the question. Let's move to the next question. The maximum force which acts on the connecting rod is. In this question we need to find that what is the maximum force which acts on a connecting rod. So the force due to gas pressure is the maximum. In a connecting rod, basically connecting rod is in the engine. So in the engine, the force due to gas pressure is the maximum force acts on the connecting rod. So the force due to gas pressure is the maximum force which acts on the connecting rod. And the next question is, three forces P, Q, and R are acting concurrently. The included angles are alpha, beta, and gamma according to Lem's theorem. So there are three forces acting concurrently like that. Let this one is P, this one is Q, and this one is R. And the angle between them is alpha. This one, this one is beta, and this one is gamma. So according to Lem's theorem, P P divided by sine gamma equals to Q divided by sine beta equals to R divided by sine alpha. This one is correct, but according to question, the included angle alpha, beta, and gamma. So P, Q, and R. So the angle in between Q and R is alpha. So if we take this alpha and this one is This one is beta, this one is correct, and this one is gamma. So we find out our correct answer is P by sine alpha equals to Q by sine beta and R divided by sine gamma. According to the concept, this one is correct answer. If we take randomly these angles, then this one is correct. But according to question, this one is the correct answer. So our correct option is option A. Let's move to the next question. The force applied on a body of mass 100 kg to produce an acceleration of 5 meter per second square is. So the mass m equals to 100 kg and the acceleration a equals to 5 meter per second square, and we need to find the force applied on a body. So we know the formula F equals to m a, and the value of m is 100 and the value of acceleration is 5. So the answer is 500 kilogram meter per second square, or we can simply say is 500 Newton or 0.5 kilonewton. And the correct option is option C. Here is our next question is, it is based on the Lemmy's theorem. Two identical trusses support a load of 100 Newton. As shown in figure, the length of each truss is 0.1. Cross-sectional area is 20 millimeter square. Young's modulus E 200 gigapascal. The force in the truss AC. We need to find the force in the truss AC. So according to Lemmy's theorem, first we need to find out this angle. So let's, this angle is alpha and this whole angle is 180. So 180 equals to alpha plus 30 plus 30. So alpha plus 60 equals to 180. Alpha equal 180 minus 60. So the value of alpha is 120. Apply the limit. These terms, each stress is 0.1, 200 millimeter square is the area, and Young's modulus. These are just not not required in this question. We need to find the force, and we have all required terms to find the forces in the truss AC. So apply the Lemmy's theorem. 100 Newton divided by angle sine of the angle between other two sides. So this one is sine, and the angle between AC and BC is 120 equals to, we need to find the force in truss A and C. So we take this one is force AC divided by angle between 100 Newton force and the force BC. So this angle is also 120. So sine 120. Sine 120 and sine 120, these two same forces, and so these are cancelled. And the force in the truss AC is 100 Newton. In this video, we discussed 6 questions. In the next video, we discussed more questions based on the engineering mechanics. Thank you so much. Please like, share, and subscribe the channel. Thank you so much.